Good morning, students. The last class we discussed about the expression for the first order reaction, and we also discussed that half-life period, and we also discussed half-life period for the zero order and half-life period for the first order. Now we are going to solve some problems based on that. Okay, you see the first question, the time required to decompose okay, SO2Cl means thionyl chloride to half of its initial amount is 60 minutes. Okay, 60 minutes means, you see, while reading only question you want to write the given, you can easily identify that time required to decompose thionyl chloride to half of its initial amount is 60 minutes. Means they are giving the time is 60 minutes. Okay, next 60 minutes. If the decomposition is the first order reaction, means we know the first order reaction, that formula is K is equals to 2.303 by T log R naught by R. Correct? No. First order means the decomposition of first order. Calculate the rate constant of a reaction. We want to find out K. We want to find out K. Yeah. You see, they are telling that half of it. Correct? No. Half of it means we can tell that R is equals to 100 minus, for example, the completion of reaction is 100%. Then they told that, you see, the time required to decompose half 100, they'll half means 50, shows 50. Then R naught is equals to 50%. Okay, R is equals to 100, R naught is equals to 50. Why? Because R is complete. R naught is 50. Do you understand here? Sorry, I have a little bit confused. I will write once again. You see, R naught means initial amount is 100. After that, what happens? The time required to decompose means first it has 100, then it becomes to half of its initial amount. Initial amount is, if you take 100, it becomes half of means 50. Correct? No. If you substitute the value of in the formula, K is equals to 2.303 by T. T they are given in 60 minutes. 60 log R naught means time, means overall time. If they are not given, we want to take an as 100. Then we are telling that to half of its initial amount. Initial amount half of it means 50. Can you understand? Yeah, it becomes 5 2s are. Okay, 2.303 by 60 log 2. We know the value of log 2 is 0.3010. Okay, if you substitute, we'll get the value 60 into 0.3010. Yeah, if you calculate, we'll get the value 0.0115 minutes per minute. Why I am taking 1 minutes? Because the question they given in time in minutes. Okay, do you understand this? Yeah. Next we are going to solve the another problem, that is a first order reaction. First order reaction means we know the first order reaction as rate constant. The first order reaction as rate constant, where they given the value means they giving the value is K. K is equals to 1.15 into 10 to the power of minus 3 per seconds. How long will 5 grams of reactant take to reduce to 3 grams? Means they are telling that reactant 5 grams to 3 grams is changing. You understand? Yeah, 5 grams to 3 grams. If you go, means R naught to R, because it is initial, it is product. Okay, now we have the formula. Then they're telling how long will be the reactant, means how long, means they're asking the time. They're asking the time. We have the formula K is equals to 2.303 by T log R naught by R. If you want to find out T, no. T is equals to 2.303 by K log R naught by R. We know the value of the K is 1.15 into 10 to the power of minus 3 log R naught is 5 by 3. 5 by 3 means 5 by 3. If you get the log 5 by 3, you see for log 5, log it is m by n. We can write that log m minus log n, correct? No, then it becomes log 5 by 3 means log 5 minus log 3. What is log 5 value? 0.6990 minus 0. Log 3 value 0.471. We'll get the value 0.2219. Okay, then if you divided by this, you will get the value 2 into 10 to the power of 3 into the overall log 5 by 3 is 0.2219. What is the T value? If you multiply, you will get that value 0.4438 into 10 to the power of 3 seconds. 3 seconds. You understand this? Yeah. Because why I am taking in seconds? Because in question also they taken in seconds. Okay. Next we are going to solve the another problem. That is, you see, the first problem is the first order reaction is 50%. The first order reaction means they are telling that first order. We have the formula to first order. K is equals to 2.303 by T log R naught by R. Correct? No? Yeah. First order written is 50% complete in 80 minutes. You see, they are telling that 50% is complete in 80%. Means similarly they are telling that 50% is completed. Means if you take 100, it's completed by 50. Means same what we solved in first. Okay, it is R naught, it is R. Okay, 50%. Then complete in 80 minutes. They are telling that 80 minutes means T is equals to 80 minutes. Correct? No? Similarly, K is equals to 2.303. T is 80 minutes. Log 100 by 50 will get 2. Log 2 already I told the log 2 value is 0.3010. Then what if you divided 2.303 divided by 80, we will get the value 0.028 into what is the log 2 value? 0.3010. The overall we get the rate constant is 0.00863 per minute. I am writing in minutes. Okay. Yeah. Next we are going to solve another problem, that is a first order reaction is 70% is completed. You see, it's telling 70% is completed. Means R naught is equals to 100. Correct? No? R naught is 100. If R is equals to, is completed, first order reaction is 75% completed. Means in 100 74% is completed. Then how much is there? 25%. Do you understanding here? 25%. Then R is equals to 25. Complete in the 30 minutes. They given the time is 30 minutes. Find the rate constant. They telling that first order. No, first order means K is equals to 2.303 by T log R naught by R. 2.303 T is 30 log 100 by 25. 25 fours are, see, 25 fours are correct. No, then it becomes log 4. What is the value of log 4? Log 4 value is 6021. Okay, if you divided 2.303 by 30, we will get that 0.07676 into 0.6021. We will get overall 0.0462 per minutes, the rate constant value. You see, next, a first order reaction is found to have a, means they are telling that first order, okay, first order is found to have rate constant. The first order means they are telling that rate constant K is equals to 5.5 into 10 to the power of minus 14 per second. Calculate the half-life period. We know that the first order half-life period for the first order is 1 by half is equals to 0.693 by K. Then we are substituting that 0.693 by K is nothing but they given the value of 5.5 into 10 to the power of minus 14. Then what happens? It's okay. What happened? It become, if you divide it, we will get the value 0.16126 into 10 to the power of, if it becomes upper side, it become 14. Then it my seconds is then below, no, per second. Then if goes to upper side become seconds. T of is equals to 0.26 into 10 to the power of 14 seconds. Okay. Next, we'll take another problem, that is a first order reaction is 50% completed. Means 50% is completed means R0 is equals to 100, R is equals to 100 minus 50 is 50. Okay, completed in 80 minutes. Calculate the rate constant of the reaction. First order, okay, calculate the rate constant. They given that the first order reaction is 50% completed in 80 minutes. Similarly, K is equals to 2.303 by T log R0 by R. R0 is nothing but 100. If R is equals to 100 minus is completed by 50%, correct? Now 50%, okay, we'll get, if we substituted, then they told that in T is equals to 80 minutes. Okay, 2.303 by 80 log 100 by 50. 100 by 50 will get 2.303 by 80 log 2. We know the log 2 value is 0.3010. If you substitute, okay, 3.80 by log is 0.3010. Okay, 0.1030. If you multiply, you will get the value. Is 8.66 into 10 to the power of minus 3 per minute. This is the value. Okay. Next, we are going to discuss about last topic of this chapter, that is for PU purpose, that is pseudo first order reaction. first order reaction. Okay, see, pseudo first order reaction. Pseudo first order means, you see, pseudo, the word pseudo is nothing but false, means I am telling that pseudo means false. Okay, false first order, or pseudo you can also call pseudo unimolecular reaction. They have the two names, pseudo first order reaction or pseudo unimolecular reaction. What it tells, you see, pseudo is nothing but it's a chemical reactions which appears to be have a higher order, means it is higher order which is made to flow the first order. It means it flows like a first order, but it is higher order kinetics. Okay, by taking all the reactants in a larger, okay, or excess. For example, we will take what will tell means hydrolysis of sucrose. Hydrolysis. I am taking for example hydrolysis of sucrose is C12H22O11 plus H2O gives C6H12O6. It gives glucose plus, I'll write straightly, fructose. Okay, if you talk, you see, this is, it's a chemical reactions which appears to be higher order, means it higher order which is made to flow in first order, means it is will be higher order but made to flow in first order. Okay, the rate K sucrose C12H22O11 is 1, but we are making to 1, but it shows higher. Okay, higher, then the order is 1. This is nothing but we will define now definition. Okay, define a chemical reaction which appears to be of higher order. See what I am telling, it's a chemical reactions which appears, means while seeing it shows higher order, which is made to flow first order, kinetics by taking all the, it means to flow as a first order by taking all the reactant in large excess, by taking all the reactants in larger excess except one reactant. Okay, we can take example like ester. We'll take ethyl acetate, or we'll take one example that is we will take that as ester. I will take ester. Ester is nothing but CH3 COO C2H5. Ethyl acetate, or also called as ester, it reacts with water molecules, okay, in the presence of hydrolysis, protonations, CH3 COO H plus C2H5OH. Okay, and written the chemical reaction. Okay, when T is equals to 0, what happens when T is equals to 0? it mole is 0. Means the ethyl acetate mole is 0.01 mole. Okay. Then water we am taking excess, that is 10 mole. Then acetic acid shows 0 because time is 0. Then ethanol shows 0. When it changes, T does not equal to 0, what happens? The ethyl acetate becomes 0. Ethyl acetate becomes 0. It becomes approximately 10.001 or see 10 minus, I am telling you 10 minus 0.01, it becomes 9.99 mole, or you can write approximately 10 mole. ಇಲ್ಲಿ ನಾನು ಎರಡು ತಗೊಳ್ತಾ ಈಥೈಲ್ ಅಸಿಟೇಟ್ ಮತ್ತು ವಾಟರ್ ಎರಡು ರಿಯಾಕ್ಟ್ ಆದರೆ ಇದು ಎಕ್ಸಸ್ ಇದೆ, ಇದು ಕಡಿಮೆ ಇದೆ, ಅರ್ಥಕ್ಕದು ಎರಡು ಇದು ಮಾಡಿದ್ರೆ ಏನಾಗುತ್ತೆ ನಮಗೆ ಅಪ್ರಾಕ್ಸಿಮೇಟ್ಲಿ ಅದೇ ವ್ಯಾಲ್ಯೂ ತೋರಿಸುತ್ತೆ. ಯು ಅಂಡರ್ಸ್ಟ್ಯಾಂಡಿಂಗ್ ಹಿಯರ್? ಓಕೆ. ದೆನ್ ರೇಟ್ for ethyl acetate it becomes, or acetate becomes 1 equals K CH3 COO C2H5, it becomes 1. For water molecule it is excess I am taking, but we will be writing as 0. Okay, the order 1 plus 0 is equals to 1. Okay, 1. This explains the pseudo first order reaction. You see, it's complete your chapter, but if you when we go for objective purpose, it's a very very important topic. Okay, very very important topic, that is Arrhenius equation. Arrhenius equation, that is Arrhenius equation. Arrhenius equation. You see, we not have to derive the equation for your PU. Straightly we will write K is equals to A e to the power of EA by RT. A by RT, where K is equals to rate constant. K is equals to rate constant or velocity constant. A is equals to Arrhenius factor. Arrhenius factor. Then we'll talk EA by small EA by RT is equals to fraction of the molecules having energy greater than EA. Okay, what is EA then? EA is equals to activation energy. EA is nothing but activation energy when R is gas constant. T is temperature. Then you see, we got this formula. This is very very important because they ask write the Arrhenius equation. Means actually this year they while reducing the syllabus they remove this, but in every year it is very very important question. For that purpose only we are doing for your objective purpose. Okay, Arrhenius equation. If you take log on both the side, equation 1 we are taking log on both side. Okay, or we are taking ln K is equals to ln EA by RT. It is like in the form of log. Okay, it is in the form of ln mn is equals to ln m plus ln n. Do you understanding here? This is in the form of like this. We will write ln K is equals to ln A. Okay, ln A plus ln e to the power of EA by RT. We know that ln e to the power of EA by RT becomes minus EA by RT. Why it becomes? The ln is nothing but log base e to the power of e it becomes. For that, it overall will tell that, okay, ln k is equals to ln a minus ea by rt. This is equation number 2. Okay, we know that ln may be converted into 2 point, means ln is nothing but 2.303. okay, ln e base 10. okay, this is the word like get. ln is equals to, we'll write 2.303, correct? No, log k equals 2.303 log a minus ea by rt, dividing by 2.303 will get log k equals log a minus ea by 2.303 rt. It is equation number 3. Okay, we got equation number 3. You see, very very important for one equation and second equation in lengths, third equation in logs. Okay, do you understand here? See, for example, if equation number 1, if we taken is T1, temperatures be changing. If temperature changes, the rate constant will be also changes. You see, for example, in equation number 1, okay, equation number 1, what is there? Ka is equals to e to the power of ea by rt, correct? Now a by rt. For this we are getting log value in equation number 3. If you change t is equals to t1, then k is equals to k1. Temperature changes, correct? No, rate constant also changes. Then log k1 is equals to log a minus ea by 2.303 by rt1. Similarly, if you take t is equals to 2, k2, log k2 is equals to log a minus ea by 2.303 by rt2. See, this is equation number, take 4 and 5. 4 and 5. Okay, 4 and 5 equations. The equation 5 minus equation number 4. Equation 5 minus equation number 4. Then we'll write log k2 minus log k1 equals minus, we are removing the similar terms, 2 point, correct? No, 30 rt2, because log a is cancelled, minus of minus ea by 2.303 rt1, correct? No, we can write it is like a log m minus log n. We can write log k2 minus k1, correct? No, if you remove the constant terms on one side, it becomes ea by 2 point. Okay, you see, the log k2 by k1 is equals to, if you remove the constant terms on left hand side, it becomes ea by 303 by r. Okay, then or 1 by t1 minus 1 by t2. Okay, if cross multiply, the overall equation becomes log k2 by k1 equals ea by 2.303 or t2 minus t1 by t2. Okay, this is equation number 4. See, while discussing the Arrhenius equation, we got 4 equations. First equation is k is equals to e to the power of small ea by rt. Another equation is ln k is equals to ln a minus e to the power of rt. Okay, next third equation, log k equals log a minus ea by 2.303 rt. Next last, log k2 minus k1 equals ea by 2.303 r t2 minus t1 t1 t2. Okay, we got the four equations. Okay.